Hey guys, welcome back to chapter 13. We are going to work through another perfect square example. So here we are. The reaction flask initially contains 0.84 molar of P4 and 0.8 molar of O2. What will the concentration of P2O be at equilibrium? So again, we're given initial concentrations, we're asked about equilibrium concentrations, and our K value is given. So automatically this is going to be an ice table, and then we'll see kind of what information we have to solve it with. So I'm going to go ahead and draw that ice table out. We've got our reactants, P4, O2, our products, P2O. I always like the coefficient in there. All right, so it says reaction flask initially contains 0.84 of P4, 0.84 of O2, no mention of our product at all, so we can assume that that is 0. And then that's it. And we have the K value. Okay. So it looks like we're going to be filling in our ice table with X's. So again, I look at this product. It's 0. There's only one way for it to go, and that is going to be up. If the product is going up, the reactant must go down. By what value are they going up and down? Well, reactants are going to go down by a value of X and X. Our product is going to go up by a value of 2X. So at equilibrium, we've got 0.84 minus X, 0.84 minus X, and we've got 2X. Now we plug this information to the K equation. So K equals products P2O squared over reactants P4 O2, and then plug in what we know. So we know that our K is 8.4 times 10 to the negative 5th. We know at equilibrium, our concentration of our product is going to be 2X, and that's going to be squared. And we know the concentrations of our reactants are 0.84 minus X, 0.84 minus X. So again, if we have 0.84 minus X times 0.84 minus X, there is a way to clean this up. So we could rewrite that as 0.84 minus X squared. And now we've got our perfect square scenario. So to fit that bill, it's got to be a squared value on the top. It's got to be a squared value on the bottom and nothing else with those squared values. That's it. So I can take the square root of both sides. So the square root is the inverse of squared. That cancels. Square root is the inverse of square. That cancels. So all we're left with is that 2X and that 0.84 minus X. I'm going to jump ahead a slide just so I have some room to work here. So after taking the square root of everything, on the right-hand side, we had that 2X on top. We have the 0.84 minus X on the bottom. And then on the left-hand side, remember we plugged this into our calculator. So we've got the square root of 8.4 times 10 to the negative fifth. And that value is 0.0092. Here, no quadratic, right? We just have to solve for that x value. So we got to get that mess out of the denominator. So if we divide by that to get rid of it, we're going to multiply by 0.084 minus x on the bottom. On the top, those cancel. Whatever I do to the right side, I also have to do to the left side. So 0.84 minus x. All right, so to solve here, we're left with just 2x on the right-hand side. Now I'm going to distribute that 0.0092 through. So 0.0092 times 0.84 equals 0.0078 minus, and then I take this 0.0092 times x. We have 0.0092. 0.0092x. Now we want to get our x values on the same side of the equal sign, so we're just trying to isolate x. So to do that, I'm going to take the inverse of this, which is plus 0.0092x. Plus, minus, those cancel. Whatever I do to the left side, I also have to do to the right side. So plus 0.0092x. So what we are left with here is just 0.0078. And on this side, we've got 2.0092x. And to finish our thought here, to get x by itself, we do the inverse, which is to divide 2.0092 on top, on bottom. They cancel. Whatever I do to the right side, I have to do to the left side. Get that x equals 0.0078 divided by 2.0092, and we get that x is 0.0039. We are not done with the problem. We have solved for x, yay! But we have not solved for what it is asking for. It is asking for what is the concentration of P2O at equilibrium. So it's asking for this right here. So the concentration of P2O at equilibrium. So we decided that x equals 0.0039. Concentration of P2O at equilibrium is 2x. So concentration of P2O at equilibrium is 2 times 0.0039. And we get a value of 0.0078 molar. So that is our answer. Again, we had that scenario where we had a squared value on the top, a squared value on the bottom. That created a perfect square. We could take square root of both sides. No longer is it a quadratic. And so now it's a little bit easier to solve. I hope you guys found this helpful.